So, what do we do with Lua in Ceph? Um, I always like to start from this awesome slide from Sage saying, what is Ceph? And one of his definitions is Ceph is an open source and free tool and so on. And I would like to, and running community hardware and so on. This is a great slide, but I would like to dive a little deeper into those definitions. So first of all, well, Ceph is free to use. Um, it's free from vendor lock-in, so bring your own device. And it's free to change. So this is the essence as being an open source. But there's a small disclaimer here, because Ceph is also 2.5 million lines of code of C++ with lots of moving parts, lots of daemon, lots of dependency. And well, although anyone in theory can go on, hop on the GitHub repo and make their own modifications and enhancements and so on to the project, uh, they usually don't do that. So some of the users of Ceph are uh, big corporations that have advanced development tools, development teams, and they actually do this work. But not all of them. And not all of them has professional C++ developers, and not all of them are actually daring to make those changes. So to try and kind of pave the way for these guys to participate more and allow them to do more tweaks um, into Ceph, we also do things that really opens Ceph to the world. Not just open source, but really open Ceph. What do we do there? So couple things, and those are all things that are already in Ceph and Redis Gateway and the other things. And we have object classes, or what we call CLS. Those are C++ code, but those in confined environment that you can inject into the OSD and run them there. And that's going to be much easier than actually changing the code of the OSD, and especially it's built for all kind of enhancements and tweaking and so on. But this is still C++. You can also inject Lua, and this is something already existing. So you can inject Lua object classes to run inside the CLS, and this also opens up a whole bunch of applications and capability. There's a great talk. You can check it out on YouTube from Noah Watkins about how to do the Lua object classes. There are bucketifications. Here you don't exactly inject code into Ceph. You're actually allowing the Redis gateway to send messages to an external system that could be like a Kafka message bus or an AWS Lambda and many other options, and notifying them what's going on inside the Redis gateway. This actually enables all kind of applications and things that to interact with what we do inside the Redis gateway in Ceph and have opens up lots of capabilities. Those applications, they're written outside of Ceph, they're written in Python or Java or whatever tools that are more commonly used by users. There's cloud storage, there is S3 select options, there's many things that we do in order to open up our product to people that don't want to actually change the core behavior in C++. And here I'm going to present what we do in adding Lua to the RGW. So why is it important? Well, um, we provide infrastructure to do storage, but the people that interact with us, they're applications. And quite often, we cannot envision upfront everything that those applications need. And sometimes they need very special integration points or special behaviors that we cannot provide, or it will take us lots of time to provide, or we don't even want to provide because they're like ad hoc integrations and so on, and behaviors that we don't really want to change. We don't want to make our configuration a monster so that each and every behavioral option would be encoded there, but we still want to give the power to the application developers in our customers and users to actually have what they need. So, like, they own Ceph and they should be able to write the ending or finish up the actual behavior, and we want to enable that. So I've listed all kind of options that we already support for enabling that, and I want to now put more emphasis on the new stuff that was recently added. So why did I choose Lua? It's a mature and powerful language, so it's not like a toy language. It's been there for a long while and has lots of libraries, um, and you can do lots of stuff with it. It's easier to learn, and this is because, well, maybe not many people know Lua as a language, but the learning curve is very, very steep. I mean, very, very easy. So it will take you very small amount of time to actually get a grasp of the language and do stuff in it. It's lightweight, which means that you can spin a Lua VM with almost no cost, which means that if you want to handle different contexts at the same time, you don't need to have complex locking and concurrency mechanism. You just spin multiple Lua VMs, and each VM handles their own context, their own request, their own flow of things that they need to handle, and this doesn't have a lot of overhead. So you can spin them up, kill them, and have many of them, and that would not impact your overall performance significantly. It has very efficient integration with C and C++. This was the actual intent of it, and the idea is there's no complex marshalling and near-marshalling when communicating between Lua and C or C++. Everything is either basic types or just pointers to structs. So this is another reason, and it's already in Ceph. It's in the Lua object classes. It's in the in CephFS and in other places. Only reason why not Lua, because it's not a very common language, but it's easy to learn, so I didn't feel that this is a good enough reason for not using it. Key concept in what we're trying to achieve here. So the our users are not programmers. This is coming back to the first thing, that we don't want the whole thing to be complex. We want to expose simple APIs that anyone that really used to write something like Python code or something like that can easily grasp and use. We want to hide the internal structures and keep the API consistent. So even if the underlying C++ code changes, the APIs are the same, and the APIs should reflect something that is meaningful for the business purposes and not necessarily our internal structures. Zero copy, everything, all the complex structures that we're exposing is all pointers that we're exposing. We don't copy anything. And zero install, which means that we are providing already built-in hooks into the Lua packaging. So if you're dependent with other Lua packages, we already have the mechanisms to do that. We spread those packages or the information about the packages using Redis itself, so you don't need to go on machines and install stuff manually. Going a little deeper just to see this example. This is an example of saying, okay, let's say I have an integration problem. My clients don't send some metadata that I need, and I need this metadata to have some specific value under some conditions for the rest of my mechanisms to work. And if I cannot change the clients, and let's say I'm a support engineer, then I have a problem. And here is an example of how Lua can breach this problem. So I write a simple line of code. It runs in the context of the request. We have different contexts, but this is just one example. It runs in the context of the request. It can check stuff from the request, like, is this a put object request? And it can modify things inside the request as if the client have sent a different piece of information here. So as you see, you don't need to create local variables. You don't need to new or allocate or do anything. It's just there. The request is just there existing in the context. So it's easy to understand what we're dealing with, and you don't need to do any boilerplate coding in order to get the request. And you just use simple syntax, dot, and get into some subfield of the request. Again, there's no copying, there's nothing here. All those things are just reflecting, traversing those internal data structures under the hood. But from this perspective, it just looks simple. As I said, everything is just pointer under the hood. Now, when you want to modify stuff, as in this example, Lua has those mechanisms. So here again, I'm not copying anything except the string my value into this new metadata field. Under the hood, there are already data structures that hold those maps and so on, but I don't need to copy them around. I just need to traverse the pointer, traverse the structs, and then put the value, and just copying this value into the right place. And the syntax just makes sense. So anything that makes sense to be a map has a syntax that looks like a map, where you have brackets and you can look up via strings, and other things don't have this syntax. So once you look at the reference manual, then you should immediately understand how things work without understanding anything about the underlying data structures. Next steps. So we want to expose the content of the data emoji in Lua. That would allow lots of applications and integrations and all kinds of things that could work there. That could be like compression options or breaking objects into smaller objects through some logics and so on and so forth. There's a project called Zipper in the RDW that wants to have a generic backend instead of Redis, and we can have a Lua layer there as well to do more logic. And as Mike just mentioned, there is a GSOC project that is showing how we can have an ad hoc endpoint for bug notifications. In this case, the NATS message bus endpoint that we're going to expose through Lua because it doesn't justify us to add this as a proper endpoint in C++, but for the purpose of an ad hoc integration or demonstration, it is ideal. And of course, the whole thing is opening up the options. So any ideas for use cases and requirements that we can achieve via this Lua integration are more than welcome. That's all. Thanks.